Vertical circles is a circle that you're spinning that is going against gravity. Okay, so you're spinning like when you hold onto a bucket, you spin the bucket, so it's like this way, as opposed to your horizontal circles. So when we draw our picture of it, it's actually a side view as opposed to a top view. Usually, when I'm doing vertical circles, you do a lot of questions that you explain how, and not many people know that when you get your physics degree, you learn how to fly. That's like a 4th year course. So usually I draw pictures of myself like flying in a vertical circle. So there's me, and I fly this way, and then I could fly in a circle this way, and then you'd fly this way, which works well for a lot of examples. Me flying in a circle, but it doesn't actually work well for specifically explaining vertical circles. So we need to explain it into something that's got a little bit more of a tangible feel. So what we need to do is we need to have a rope in there so that we can have tension. So what we'll do is we'll put me at the center, and I will tie a rope to one of our favorite chemistry teachers. And what I will do, being the physics teacher, is I will spin the chemistry teacher in a perfect vertical circle of radius r when I don't want to mess things up, so I'm not going to bother putting an r in there. Okay, so you have the situation set up. We're going to examine this just at the top point here because we want minimum velocity, and at the bottom of a circle, at the side of the circle, those aren't going to be minimum velocities. In fact, this is going to be your maximum velocity, and this is going to be going faster, and this is going to be slowing down. Okay, so we want to figure out in our situation where in the end we have constant velocity, what's our slowest constant velocity that we can go around? So it doesn't really help us to have slow constant velocity in here. We can go faster or slower, it doesn't matter. Same with down here and here. But to go in a perfect circle, constant velocity has got to be slow, and you basically want to limp around as slow as you can here without the circle collapsing in on itself. So that's what our minimum velocity is. So that is what we're finding right there. But we're trying to find the minimum one that we need. So not all the velocities are different. They're just the slowest possible one that you can get. So at this top point, our favorite chemistry teacher has got two things. He's got a force due to gravity, as well he's going to feel some sort of a tension towards the center of that circle. Now, if we do a sum of forces here, but I'm not going to bother writing, I'm just going to logically explain this. You're going to say I have a force due to gravity, plus I have a tension, and that's going to equal, because it's circular motion, my FC value. But I'm telling you that I'm trying to go at my absolute minimum. So if I manage to create the minimum velocity situation, when I get to here, the tension should actually be zero. You shouldn't feel any tension pulling you down at all because you've minimized the velocity. So really, Fg is going to be equal to Fc. That means that mass times gravity is going to be equal to mv squared over r. These masses cancel, so you get g equals v squared over r, which gives you v equals a square root of rg. So that is your minimum velocity. Notice there's no mass in here. There's no mass, which, well, that's because it cancels out up here. That means that any kind of vertical circle doesn't care what the mass of the object is. So our chemistry teacher can gain weight or lose weight, they still spin around at that same minimum velocity, which is why you can have roller coasters and stuff doing loop-de-loops and not people of different masses falling out of it, is because as long as they go at that minimum velocity, everybody stays in and you feel weightless for a second, all that kind of stuff. Okay, let's just do a little quick example. Let's say that we take our chemistry teacher and we're going to tie them to a rope and we're going to spin them around in a radius of 15 meters. And we'd like to know the minimum velocity that they will experience at that rate. Well, square root of rg. Radius is 15. I'll use gravity to be 9.8 just because every once in a while I feel like I should. 15 times 9.8, square root of that. So you end up with 11.9. I'll just call it 12. meters per second. That's the minimum velocity that you can travel in this 15-meter vertical circle at. Now, if you wanted to, you could just times that thing by 3.6, and that would tell you like 43 kilometers an hour. Okay, that's how fast this actually is, and you can see that's not very fast, which is why you're able to make roller coasters and stuff like that. There you go, vertical circles.